the question was, what's the difference between double with capital D and double with lowercase d? Um, let's talk about this box values. Basically, when you have primitives, right, you cannot use them by reference. Primitives are um, the actual value, right? They don't have anything. They don't have an identity different from their value. Sometimes we want to pass references instead of values, and so Java created boxed primitives. They're basically a class that just contains one element of a primitive. So, and of course, right, they couldn't be consistent because that would be useful. So the name is almost the capitalization of the name of the type, except when it isn't. So for int, it's integer with a capital I, not capital INT. And for car, it is character, not car. But for float and double, it's float and double with a capital. And so if you you can do stuff like this. Integer I equals new integer of 3, and that's a new object. And then I dot int value would return you the integer value. You can also use it to convert. I think you can convert. And so you can do like I dot double value or something like that. And Java has auto boxing and unboxing that oftentimes works, and it's getting better and better. So for example, I can do integer I equals new integer of 3, and then int j equals I. So it's automatically unboxed. Java automatically says, rather than I, you mean I dot int value. But you don't have to write the dot int value.
Oh, you don't have to type in that int value.
No. Java will auto unbox, and in this case will auto box. Will create a new, right? When you do I equals j, since I is an integer, not an int, it will do I equals new integer of j automatically. Does that make sense?
Yeah, I did it was small letter double.
You were doing horrible things that we haven't seen. There are some things, especially with generics, where you cannot pass primitives. Generics don't work with primitives in Java, so you have to pass objects, and so you need to use doubles with capital D.
Yeah.
You didn't really need to use them, but the way that you went.
Couldn't figure out how to Google it.
That's what happens when you Google and cut and paste stuff without really understanding. But hey, the redeeming quality is that it works. If it passes all the tests, then it can't be that bad. So now that we have talked about box values, which is good, we can talk about class inheritance and then go do maybe a cool example or two. In my line of work, class inheritance is almost always wrong because I tend to do stuff with databases, and normally you don't use class inheritance. But it can be useful. The idea is that I can define a base class. In this case, I'm calling it base person, that has fields and methods. And then I will create another class. In this case, I can have employee that extends this base person class. has other fields, and it inherits all these fields. So an employee, given that it is a base person, also has a name and a date of birth. And it also has methods getName and getDate of birth. So in this case, I could add an extra one, SSN. I could have, this is the call to the constructor for base person. I'll use super for my superclass. And then I will use my own fields. Important thing, here we are using protected. We talked about what it was, but right? Public, what does it mean? Public, anybody can access it. Private means only me, that's it. By default, if I don't put anything, I'm doing package, everybody in my package. Protected means me and my descendants, me and my subclasses. So this gives me inheritance and polymorphism. I could replace this. I could override these methods, and then the right one gets called at compile time. Does that make some sense? Rather than doing this, let me do an actual possibly usable example. How about that? And let's complicate our life. You can see the mechanics, right? Mechanics are simple. You just inherit all those fields, right? So we get encapsulation. An object has data and properties, and now we get inheritance, right? And polymorphism is one thing, multiple forms, right? Many forms, that's polymorphism. So I can have the same method, and depending on the inheritance, I could get called other methods that get called.
Do you always create a new Java file for every class, or?
It is very good manners to always create a new Java file for every class. Oftentimes, I get really pissed at Java because I end up with a class that's only 3 lines. But normally, yes, you do. And like, if I ever get pissed and don't do it, everybody in my team will signal it in the code review and force me to do it anyway. So yes, you do it. Yeah, you normally, like, in a very few cases you wouldn't, but very, very few. Only basically when the class is only used by the implementation. When nobody else would know that the other class exists, then you can. Or than that, you do it in its own class. But let me cheat and not do that. How about that? I'm gonna call expressions. Cool. I'm going to be creating tiny classes in here to represent expressions. Imagine that you have something like this. This is an expression, right? An integer expression, right? In reality, I have parentheses all over, but I don't put them, right? This is -4. This is like this. This is, I think, like this. Right? That's really what is being done. Maybe it's 3 plus 5. Let's see. Let's go to Java REPL and see how it associates. Three -1, -1. What should this return? It's either 3 or 1. It is 1. Okay. So it is, I'm putting my things wrong. This is 3 plus 5 minus 3, then minus 4, right? Yeah. Did I not? Yeah, doesn't even parse. Isn't that cool? Why? Oh. Oh, because minus gets interpreted as the minus operator, so I need a space, right? So, in general, right, when I have an expression, what kinds of things do I have in a mathematical expression? I have literals, right, which could be variables or could be constants, right, like 3 and 4, or x. What else do I have? Signs. What are those things? They are operators, right? And my operators can usually be either unary or binary, right? Like minus, right? The plus and minus signs are unary, or there's unary plus and minus, and then there is binary plus, minus, times, and those things, right? Does that make sense? Yes? So, let's define that stuff here. I'm going to define an interface expression that's going to have one thing, int, going to call eval on it, and it will give me the value. Does that make sense? I'm going to have, and I'm going to make them static class to not put them in separate files. I should, but I'm not gonna. I'm evil. A literal, and this implements expression and it's complaining because it's not implementing expression, right? So, what do I have? I'm gonna int value, right? I'm a literal, what do I evaluate myself to? My value, right? So I can have beautiful stuff like this. What would this print? cs5kOct23. So convoluted. Isn't this cool? Woohoo! Um, I could define I could make this and so if I'm a unary operator, actually, I will say that I am abstract. What does it mean? I'm not implementing it. Good. Bless you. Let me do this. Rather than doing that, let me do this. I'm going to have an operate, right? So I can actually define eval as whatever my operator does. So operate on operand eval. So evaluate my operand, and then I call my operate on it. And by default, it does nothing. Does this idea make sense? Now, I'm going to extend unary operator. I need a constructor, right? Unary minus of expression operand. And what I'm gonna override is this operate. Should this be public or maybe do protected? How about that? My operation is return minus value. By extending unary operator, I am implementing expression. So I have eval. I'm getting it from this other class. Does that make sense? So that enables me to do new unary minus of new literal of 3. And when I call e.eval, what would I get? Negative 3, right? Hopefully. Unless I screwed up. Yay! Does this make sense? Isn't this cool? Sorry?
What was at the top of it?
Literal or expression or which one?
I don't know, there's all this stuff.
We have an interface expression that had eval. That's all I can do. I can ask it, what's your value, right? I have a class literal that implements expression. It only knows about its value, right? That's a constructor, and eval just returns its value. Then I created a class unary operator. This unary operator implements expression. It has one field, which is its operand. It's going to have one thing that others can extend, which is this operate thing. Takes a value and returns whatever it does with it. Right? Unary minus returns a negative. Unary plus actually doesn't do a thing. But and then eval is going to do evaluate my operand and then operate on it and return whatever is returned by it. Does this make sense?
So we have implements that's implementing an interface and extends that's polymorphism?
Well, both of them are polymorphism, and it depends on what you are doing. If you are a class, you implement an interface, you say, I'm defining all those methods. If you are an interface, you can extend other interfaces. And if you're a class, you can implement interfaces or extend other classes.
You can implement an interface, and then someone can extend you.
And someone can extend me.
And we had super, and that's referring to...
The constructor of the superclass.
So it's almost like parent and child?
Yes, it is exactly parent and child. Superclass and subclass. Now, in terms of philosophy, right, you have is-a relationship. So we'll say, right, and if you think about it, it makes sense, right? A literal is an expression. So when you're extending an interface, when you're implementing an interface, right, you are an expression. Also, when you extend a class, so unary minus as a class is a unary operator. Does that make sense? Now, we could, and I don't know, does it make sense for you guys to just define them as abstract and not have that operate? Or I hate abstract classes. They give me the heebie-jeebies. An abstract class doesn't have all of its methods, just says my kids will implement them. But what's unary plus? Which is kind of a very useless thing, right? In fact, that's what operate does in the default implementation, so I don't even need to override it. But I can do this. Now this would do 3. Now, let's.
You do, like, not unary minus, and that would make it not a negative. So that
Oh, abs, right? We could do abs, right? Imagine that we had an operator. Right?
Do you always have to use that super keyword every time you use a method from a?
It's not a method, it's the constructor. There is no good way of expressing it. I could implement it myself again, but it's better manners to call the other guy's constructor.
So it's used for constructors only.
Only for constructors. You could use it to explicitly reference the method of the superclass if you override it. So I could do.
Oh, okay. So it does have another use. It's just not as common.
Yes.
is that so it makes it more generic, where if you don't have an override, then it'll take the superclasses attribute and it'll,
By yes. It's a method, not an attribute. Yes. I cannot override attributes. I just get them from the superclass. I can add more, but I can never change them.
It seems complicated. You have a superclass and a subclass with the same method, though. Like you're like, oh,
That is the point. I need to override the method. That is or at least, yes, it is complicated, but that is many times the point. What I want is to be able to override a couple of methods and so change behavior. Interfaces are nicer, but yeah, let's what's a binary operator? What are we going to have? What are my fields? We're going to have two operands, right? Maybe left and right. What kinds of things are those? Sorry? They could be plus or minus, they could be literals, they could be other binary operators. So what are all those things called? Expressions, right? They're all expressions, right? See that I call them left and right.
operators are there besides binary operators?
Unary, like minus and abs. Actually, we see commonly ternary. There's one ternary operator, which I use here on purpose. The question mark operator.
Oh, what does that do?
What does that do?
Oh, it's just another if statement.
It's like an if statement, but returns a value, right? Yields a value.
Are there ternary operators in math?
I have no clue. What math have you seen? I bet you there are. It's just they're not common because they're hard to write in math. You tend to write them as functions rather than operators. But this ternary operator is commonly used. I have no clue what math have you seen.
Yeah, I had a dream once that there were lots of
Me too.
I try to remember if there is a ternary operator. Not in any of the commonly things that I see in
Okay,
math.
I thought maybe
Actually,
there
if
was
you
like
think
easy
about it, yes. Stuff like summation, right?
Mm.
Summation actually takes
Yeah, a bunch
a
of
gajillion things, right? Integrals, what did we call?
Index.
Coded or the integrals with mean and max, right? Determined integrals, or right? You take the function and then the minimum and the maximum value of x, right? Definite integrals, right? Those are actually ternary. You take the function and the two, right? Things and summations and
Okay. We'll just do the binary ones.
yeah. Let me, just to show, right? Let's make this one abstract. That means I don't have all my methods. I'm gonna declare this method abstract. That's the abstract one.
So operate doesn't need any methods because it's just gonna like return what the other
Sorry?
Oh, okay, wait, that's not a class.
Operate is a method.
Yeah.
So public int eval.
So wait, what's the abstract method do? Abstract class is not gonna have any methods.
No.
Abstract method.
An abstract class has at least one method missing. May have methods, but it's missing at least one. So you can never instantiate an abstract class. You have to instantiate any of its children. An abstract method is one that is not implemented. In this case, we are saying operate is not implemented. Isn't this cool? So I would have Now I can do binary plus of new literal of 3, new literal of 5, or new unary minus what would this return? -2, right? If we did this stuff right.
To go back and follow all of that. So let's see, super left of right. So it's implementing the constructor.
It's calling the constructor.
Of so what is the super constructor?
What's my superclass? If I'm binary plus, what's my superclass? Binary operator. So it's calling the constructor of binary operator.
So let's look at the constructor of binary operator. This expression. Resolves the which are expressions. The abstract protected int operates, so that's not, it doesn't say that it's doing anything. I'm trying to understand
That says my children have a operate method, but I don't.
Oh, okay. So all you're doing is you're kind of like, it's almost as though you're like declaring it or something.
Yes.
Okay.
I'm declaring that my children have to implement this, and if not, you can never instantiate. Given that binary operator is abstract, I can never do new binary operator. Right? Java wouldn't let me because it's an incomplete class. It doesn't know how to operate.
Oh, there it is. Operate.
Abstract means it's missing, abstract on a class means it's missing at least one method. Abstract on a method means I'm not going to define the method. It's missing, my children have to define it. So in binary operator, it's an abstract class because it's missing at least one method, and the method I'm missing is this operator. Make sense? Questions? You could go define $700. Isn't this cool? Sorry? You need to get used to this creating layers and layers and layers of abstraction, right? Which makes it hard. Yeah.
Is there any site like Coding Pad that has some good, just like practice things of this kind of stuff?
Not that I know.
Okay, I could just go look up some problems and some book.
Yes.
Okay.
Many of the problems that you have don't, right? I mean, this one really has both inheritance and recursion. Your data is recursive, right? You're an expression, but your left and right are expressions too. So you could have this go very deeply
You
recursive.
could program this different ways. So
You could program this
it's like
different
I
ways.
could just make up my own program and say, okay, I'm going to do it with tons of superclasses and inheritance.
Yes.
And figure it out. I just need to like practice a little bit because it's not super fast. That I'm like, oh yeah, I get that. That one was that. I understand the concepts though.
Cool. Have we? Let's see what else.
I'm going to make mistakes when I try to code it. I'm going to, oh yeah, I forgot. Super.
That's normal, right? I mean, how do you make it so that you don't make mistakes?
You Google it. No, you practice a lot.
Practice. You do a million of these things, right? Kind of the standard obvious examples, but they end up being fairly. Let's do product hierarchy. This kind of ends up.
Sounds like database.
Yes. Given that you do them in databases, you never actually define classes and subclasses and things like that. But
Well, that's a super type and subtype.
it is very similar. It is the exact same thing as supertype, or it is very similar to supertype and subtype in databases, in entity relationship modeling, if you are seeing that stuff. And it is similar to subsets in discrete math, if you're seeing that stuff. It's A, right? So imagine that you have an e-commerce site. You're selling stuff. So I'm gonna probably have a product class. What's the basic info that I have on any product? Okay, let's assume that I'm gonna have an ID, string ID. What else? Manufacturer date. That's gonna, well, does everything have a serial number? Hey, I'm gonna have a, let's do protected, let's do simple stuff. String description and price, right? Now let's assume, against all evidence, that my price is simple.
In the real world, we use what normally for it's not simple. We use a string for that.
No, in the real world, pricing can be a guy's lifetime work,
And
because
notes and different.
there is it's not just it's currencies, it's time of day, right? How much? Think about how much is a Coke. You go buy a Coke, right? How much is it? 16-ounce Coke, 20-ounce Coke. Sorry? $1.89 where? You go to a football game, how much is a Coke? $18, right? So, and in different, right? They do it, but if you buy a 12-pack, right, then it's a lot less. And so it depends on who you are, depends on the date and time of the purchase, and depends on, the location, who is selling, right? Amazon and a bunch of other sites, right, actually kind of have a profile of you. And so they will sell you, travel sites tend to do that, right? How much is a flight from here to New York? God, I have no clue, right? I need 7 freaking sites just to try to search, because pricing is very complicated, right? For something like travel sites, and they will actually see that you're searching for travel to New York. So if you search 2 or 3 times, it's like, oh, you want to go to New York, so I can charge you 10 more bucks, and you're gonna buy it.
Same flight, it's the exact same time, it's like the exact same seat on the plane, the exact same service.
but
But the
you
price
get a
is
different
changed.
price than him
Yeah,
or her.
yeah.
And so, God, price should be, right, some big database of how the heck do I charge you stuff.
And on the fly searching, if you do it on a Mac and PC, you will see two different prices.
Yes, they will, right? They will use all those kinds of things to come up with,
Yeah.
oh, that's how much you can bear, right?
Do they have scrape your cookies or something?
They use all sorts of things. Many times, for travel sites in particular, incognito mode in your browser will actually get you a different price. So if you don't like the price you're getting, go incognito and see.
That's what I heard. I've never
Um,
that, but I heard it's true.
it's you never know, right? Because if you go and search half an hour later, you're gonna get a different price anyway.
Yeah, the time makes it.
But you get right all sorts of price is a horrible, horrible mess. But I'm gonna call it a double.
You guys do anything like that at the bathroom?
I actually implemented our new pricing service, and we have a fairly simple model, but we do have sales.
Like
So
price
just,
breaks?
sorry,
Price breaks on quantity purchase?
we do have both sales, just like okay, this weekend we have this on sale for 10% less, and then we have quantity-based pricing. If you buy 3, then I'll give it to you for this much, and then 2 different ways of quantity-based pricing. So it is, and we are doing simple stuff. We don't charge you more depending on who you are, right? I don't even think we have like customer discounts. Many times, companies will have a different price depending on the client, right? If you buy me a lot, then I'm gonna give you a special discount. And so pricing is horribly convoluted, and that's not even counting different currencies and things like that. So double price. Now we can do different kinds of products, right? So that's my product. Let's actually just make this thing public. It is horrible. Don't ever make your stuff public, but now if I'm a book, I may have ISBN or 2, right? There's usually ISBN 10, ISBN 13, I think. Sorry? Title, right? And I'm making everything strings, but like author, right? And this could be a collection, this could be an array of authors. And author may be its own class, right? Public, this is probably a person class, right? So this would really be more if I'm selling a CD, what do I have?
Were you created your person class up there? Would you have to make that an array? Or
What?
so the class of person, that have to be an array since you made an array?
No, the variable is an array, the class is not,
Oh, so just like you did. Okay.
right? Now, don't even get me started on names. Let's assume that people have a first name and a last name. Names are also very complicated. Because surprisingly, people want to call themselves different things. And not everybody agrees that you should have this many names. And we have 9 billion people and we cannot all do the same. I don't know why. Sorry? I don't know. A ton. A ton. I have no clue. I haven't looked recently. But a CD would probably have songs. How do we identify a CD? There's something like an ISBN, right? But title. No, they have like a barcode or something like that, right? I don't know.
UPC code.
UPC, yeah. Yeah.
But also every like product's gonna be your own like personal product code, just from like your business.
That's this guy, right?
ID, yeah.
Because by
Oh, 'cause it's a
extending
product,
product,
okay.
sorry,
That's all.
by extending product, right?
Okay.
I have ID description of product.
Forgot about that. That was the whole point. Okay.
That is the point of extending product, right?
It saves you from having to write public string ID and whatnot.
It doesn't just save me from having to write product string ID, public string ID a bunch of times. It doesn't just do that. It does that, but also it allows me to say, oh, I'm gonna have a function calculate total, right? That will add up the total for my products, right? And I can have base products, I can have CDs, I can have books, and I can treat them all as products. Does that make sense? Yeah, I cannot actually do it, but that's okay. Right? So it does two things. It actually does three things. First of all, it saves me typing, but it allows me to create polymorphic functions that operate on products and don't care if they are books or CDs or things, and then some others that operate on books and some others that operate only on CDs and things like that, right? It also helps me understand the domain if I'm starting, right? I have no clue about products and stuff like that. I can go and say, I have books and CDs as my products. Oh, that's important, right? And they are different, but the same-ish. In some sense, they are the same, right? And that sense in which they are the same is that class product, right? That has these fields and these operations and things like that. The mechanics are not that hard. The actual philosophy is hard because this is philosophy, right? Because
Yeah, you have to do a lot of thinking, and it's not like guaranteed that you get it right.
don't worry, you got it wrong. It's okay. It's normal. You always get it wrong, almost by definition.
Like if you're not returning the number you're supposed to return, you know it's wrong. But if you like have a class structure that turns out later, it's like, oh, I really should have done it this way. It's really hard to see that.
You can always change your code. You can always refactor. That's the point. You do two things actually. First, you talk a lot about it, right? Because when you're doing this, what you really are doing is talking. We come up with cool diagrams like UML and stuff like that so that we can actually go talk to normal people. Because let me tell you, the guys who are trying to sell stuff, the guys in the warehouse, they don't want to go talk about that stuff, right? They don't care. Even several layers up, they don't care. They're focused on their job. They don't want to talk to you about that stuff, right? So it is not necessarily an easy thing. But if you can talk a lot with people in the business, the really cool thing is that this makes our job so much more fun because I can go work 2 years at Microsoft on digital advertising, and besides playing with different cool technology, I spent 2 years learning about digital advertising. I didn't have a clue. Now I have half a clue, right? And then I'm working now for an e-commerce company. We have a warehouse, and so I can spend at least 5 years until I get bored out of my mind, right?
You get to meet a lot of people who are doing different kinds of things, and they teach you stuff like fantasy football and important stuff. Yeah.
Yes, you get to learn about domains, right? And you can switch every few years, and so you become a programmer. Once programming is very transferable. If you know Java, you can learn C# in 5 minutes, right? You can learn C# in a weekend of no sleep. Or you can learn, if you know web development, you can go to Android relatively easily. Not necessarily a weekend of no sleep, but you can also switch domains. So now it's not just I'm a Java guy, or I'm a databases guy, or I'm a C# guy, but also I'm a guy who has worked in warehouses. And warehousing is actually a very different domain than e-commerce. Just so we have those two domains, and you get to learn a little bit about those things. And when you get bored, you go do healthcare for 5 years, and right, and there's tons of ways in which stuff is the same. Chances are that you have to represent people somewhere. Chances are that you have products or something like that somewhere. There's tons of ways in which stuff is different, and so you can spend your whole career and not get bored. Or you can specialize and do e-commerce your whole life and become really, really good at that stuff. This makes sense. Most of these simple examples end up being like this, and so they're relatively simple. It's hard to find good domains. So we tend to do abstract domains just because it's easier. We tend to do expressions and stuff like that. Any questions about inheritance, class inheritance, interface inheritance? We have assignment N coming, assignment 8, right? That requires you to do interface inheritance, right? To implement a bunch of things. If you bug me, I'll post this on the internet, which is a lot better than
You do.
your picture.
It's on YouTube. I see it.
No, I can also post the code.
Oh,
How you
I
open
have the code.
Where?
Sorry?
How you open the code?
Go to GitHub. Go to github.com/okaram/intro-java, and that's linked from the. And at the very bottom has lecture examples.
Oh,
Yeah. And if you I can put that right now, but let me stop this and return to you 15 minutes of your life, unless you have questions. No, we're good. Let me stop recording.